today, the second homework assignment will be collected, and I do trust that I am planning to get that graded back to you very soon. So we'll begin today by, I want to just ask if there's any questions or needs regarding that particular assignment before you guys hand it in. I've been losing my train of thought a lot today. I probably need to look into that and drink more water. Make sure that I have it up here in this corner by the end of the period. Those aren't staples. Sorry, paper clips. Wow. These are paper clips because staples don't exist on this floor. Yes.
I just want to make sure I read the question right and I'll put it in my calculator right. Can you do number 10?
Number 10. Ah, yes. Log base 10 of 6.2. It's a good question because logarithms are very strange things inherently. When you, on your calculator, press the log button, it performs a logarithm on whatever you put inside of it. And in this particular case, it asks you to put 6.2 inside.
Okay, so just, okay.
Right. Most calculators are programmed such that the base standard log button is log base 10.
Okay.
Every logarithm needs a base. If there's nothing specified, we can usually assume it's 10. Sometimes though, if you want to make sure it's log base 10, someone might write this, but most machines will assume base 10. You may occasionally see log base anything really, but if the logarithm is very specifically based on the natural number that we like to use, we have a different symbol for that. That's the ln. So, a logarithm, the normal log logarithm and the ln are technically the same thing. It's just a matter of what base the system is using. But if it ever asks log base 10, your standard normal log button will do the trick. Anything else at all? At all? Okay. Make sure that I have that with your work file right here by the end of the period. The papers that are still up here are some students graded assignment 1. If you didn't collect your assignment 1, it's probably still up here. Do come by and grab it. Make sure assignment 2 is right here by the end of the period. You can bring it up now if you want to, but at least by the end of the period right there. Today, we'll continue looking at assignment 3 together and the types of things that appear on assignment 3. My plan for this week is we'll keep looking and working on 3 together. Currently, the assignment will be due next Wednesday. I definitely misstepped when I first thought it could be due today, but there's still some more things on it I want to talk about with you guys. And I'm going to tie it into some physics today. I'm going to show you some of the things that you'll be doing in, say, Physics 1500 that we'll be utilizing the formulas of this basic shape and the quadratic and things like that. And then on Friday's class, my goal is to have this assignment graded, handed back, and talk about it together. We'll wrap up this assessment, and I may go ahead and hand out the next one if you have it and work on it. In the near future of this class, I think we're coming up on our first test. Did I say that was the start of March? Sorry if not, I have my computer open in front of me.
Yeah, it's March 1.
That's what I thought. Thank you. And March 3rd. So what that means is we have this week, we're going to cover and wrap up assignment 3. Next week, we will work on one more section of material, and then towards the end of that week, we'll transition into reviewing everything we've talked about so far. The test will be an in-class assignment. You can't work together, but you can ask me questions. We'll make sure to go over the rules and regs, what all will be on it as we get closer. That is currently about 2 weeks out. If I need to adjust that, I will push it back, but I will never make it earlier. That's a general rule. So, just to remind everyone, that is coming up. We've got some time to prepare for it. And I think the coming weeks after that, we may have a day or two off, thanks to our the academic calendars when we fall. So, interesting couple of weeks ahead of us. I've already asked if there was any homework 2 questions. Any general questions, comments, concerns, needs, etc. before we get started today? Okay. Well, if you have any, at absolutely any time, about the course or anything randomly science related that pops into your head, do please feel free to ask. And stay hydrated, because I apparently haven't been, and I keep losing my place in my sentences. Yes?
For the third question that we have for quadratic, and they don't break down into like whole radicals, it can be in one number, like 25 to 5. Like if it's a decimal number, do you need to change it with like
No.
all six and?
A decimal answer is more than okay.
Oh yeah, I just didn't know if we need to have like imaginary numbers in there for that.
None of these, hopefully none of these are set up to give you imaginary numbers.
I think number 8, I can, or one of them, I think 13.
Yeah.
There was a negative 2.3 in this third group, so it said negative.
Yeah, for 14.
Oh, okay.
Yeah, for 14, I got eyes.
Okay, that's fair. We can actually look at those ones specifically as examples today. The thing about all these questions is they're going to give us 2 answers at least. And typically, that usually, if one of them is imaginary, that means it's definitely the one that won't work in reality. Because when we are doing these types of things in physics, sometimes there's 2 numbers that will make the physical situation make sense. Sometimes there's only one of them that will make the physical situation make sense. To give you a real physical example, something specific that you will be doing in your upcoming physics courses, let's look at, just as a sample, a projectile motion question. So what we have here is a poorly drawn cannon on top of a building. And just to go ahead and put the vocabulary in your head for when you see it later, we're going to examine projectile motion, the motion of the projectile, that is the cannonball. So let's fire a cannonball out of this hypothetical cannon. It's fired in a direction at some velocity. So it has a starting velocity and some starting trajectory. So we're going to be, in future, we will be analyzing various vectors like how fast things are moving and what direction they are moving in. Because velocity, by definition, has to have a direction. If you've ever watched, this movie's getting a little dated now, the first Despicable Me movie had Vector, the character in it. It's a very convenient way to, what he says about himself is a very convenient way to remember what a vector is. So, everything you've ever fired out of a Nerf gun or what have you moves in some direction at some speed. And usually, when we look at these types of a question in a physics class, our usual goal is to try to figure out how far away this cannonball is going to land. This is a range type. You will commonly be asked range questions to find out the range of this particular projectile. And you'll be given various pieces of information like how tall this building is, the launch speed of the cannon, various things to that effect. And there's another variable that will come up all the time, so it's good to go ahead and get this number in your head. And that is the acceleration due to gravity. So, has anyone never seen this number before? And then that is okay. That's why we're talking about it now. This number is in metric, so this is in meters per second squared. You might have used it in something similar in feet per second squared before, depending on what classes you've had and where, is the acceleration due to gravity. This describes on Earth's surface the rate at which things fall. Specifically, the acceleration of falling, though. When you drop something, it doesn't drop at a constant speed. It gets faster and faster until it goes splat, which is why jumping 1 foot off the ground is no big deal. Jumping 10 feet off the ground will hurt because you've had more time to accelerate to a higher speed. Yes?
Isn't there like terminal velocity though? Like once you reach a certain speed, you stop?
Yes, that does come up. That depends on gravity where you are and also air resistance. So you have to factor in your density and your shape and what speed you're moving at. And that is an upper level physics thing because the formulas for figuring out air resistance on a non-uniform object are not fun. So, spoiler alert, most of the physics classes that you guys will likely take will be ignoring air friction for simplicity's sake. And you're absolutely right. You're accelerating at this rate until eventually you get uniform velocity. And the combination of height above the ground, launch velocity, accelerating downwards the entire time you're falling creates a very specific motion pattern. This cannonball is probably going to be lobbed along a path that looks something like this. Blast something out and up, it'll go up, and then gravity pulls it back down. This is the motion of the projectile. And we can describe this motion with a particular formula. And it's one that you've actually seen before. It's been on one of your previous assignments, even if we didn't assign any meaning to it. dF final equals d initial plus v initial. I realize I'm using 2 different symbols for initial. That's my mistake. V initial plus vi initial. Sorry, let me start over. Distance final equals distance initial plus velocity initial times time plus 1/2 times acceleration times time squared. This formula is a very commonly used metric formula, so do get used to it. It will show up all throughout Physics 1500 whenever you take that. Is used to look at the motion of anything as it moves from point A to point B with some starting velocity and some acceleration throughout that whole process. You can use this to describe the motion of pretty much everything because this one formula has factored in how fast was it moving to start with, where was it originally, how fast is it accelerating the entire time, how long has it been accelerating, etc. It's a very, very handy formula. Most basic physics is derived from this. And it's technically a quadratic. Just replace the t with an x, and it's of the basic form to fit in the quadratic formula already. So most projectile motion fits into these types of problems. And that's why, if, say we were to solve this quadratically, solving for t, the amount of time in the air it would take for the projectile to get to the 0 point, if we assume 0 point to be the ground, time required to get to a distance point of 0, we can solve this for 2 separate times. One of them will make sense because it'll be a positive number for a time in the future where the cannonball will hit the ground. One of those times won't make sense because it'll be a negative number. It would be the time in the past that the cannonball would have been on the ground if it had somehow been fired from there instead of from the cannon, it doesn't make any sense. So we're going to be practicing these with the intention of finding all answers, but usually in physics only one of them will actually work. And it will usually be pretty obvious which one it'll be, because if it's imaginary or negative, where a negative wouldn't make sense, it's usually going to be the one that gets thrown out. But because they will come up on this assignment, if one of your answers involves a negative inside of the square root, your calculator will either complain to you that this doesn't work, or it will give you an imaginary answer. So if we were to write out the full imaginary answer to square root of -4, what would we get?
You do plus or minus 2? Plus or minus something?
It would, yeah, correct, sorry. Plus or minus 2 times I. Because I is the square root of -1. It's imaginary, it mathematically doesn't work, it's kind of like dividing by 0. But we hadn't even meant this little symbol for it because it keeps coming up in our math. Again, in physics, wherever this pops up, it means that that version of the answer is not what would actually happen or make any sense. And in terms of projectile motion, the imaginary answer usually involves some point inside the past, inside the building. But we'll work a few of these today, and we'll see where the imaginaries come from and what we would do with them. Two problems that have already been mentioned today. We had 13 for a quadratic, and I think 8 for an unfoil. We can take a quick look at those. Let's do the unfoil first, and then we'll move on to talking about more quadratics for the rest of the day. 8 is interesting from an unfoiling perspective, because with the rules that I gave you for how to unfoil, there's a little extra step you have to do at the beginning. -36 plus 13x minus x squared equals 0. So this is in the unfoiling section. Our goal is not to do this through the quadratic method. Our goal is to do the unfoiling puzzle solving method. So with the steps that I listed out last time, what is step 1 of unfoil?
Put it in the right order.
Okay, we want things in the correct order. Means our x squared term needs to go first. Negative x squared. Our regular x term comes next, followed by our term with no x in it, all equals 0. So you identified what term is which, and it's now all in the correct order. What's the next step? Very good. So what is a currently? -1. That doesn't make this impossible, just makes it harder. And I like to undo the step that'll make it harder. I'd rather undo it here than undo it afterwards. So what can we do to make this +1, or to make everything else just a little simpler moving forward? We can divide every single thing here by a -1. And that will give us as our next line, -x squared divided by -1 will be just +x squared. So our a is +1 now. Next, 13x divided by -1 should give us -13x. And lastly, -36 divided by -1 should be +36, and you can't do anything with 0 that won't make it still 0. So all we did was invert a few things. Everything still means the same thing, and we can proceed from here. What is our next step? Very good. So we're going to take a look at our C term, find every single combination of things that can multiply together to create this number. And we are going to have to look at negative combinations too, specifically because eventually some things are going to need to add up to form a negative number. So, but let's just go ahead and get started. We're going to look at 36 and find every pair of things that can multiply to become 36. You can always start with the simplest one. 1 times anything creates that thing. So 1 and 36 are a possibility. If we can just start going through I recommend looking at the first pair and just increasing the first number. What times 2 would be 36? Good. So we have 2 and 18. What times 3 would be 36?
Whoa.
Very good. And does times 4 work? Sorry. 9. Thank you. 5 doesn't work. 6 does work. 6 times 6. And that should end it. Because if we keep increasing this first number, then we just start retreading the same territory. Now our number here is positive, meaning we can get there from either a positive times a positive or a negative times a negative. So for all of our candidates, the negative versions of everything are also on the table. So -1 times -36, -2 times -18, etc. Out of all those candidates, we want them to add up to -13. So who's looking most likely?
4 and 9.
Very good. 4 and 9, but specifically
Negative.
-4 and -9. So that should give us x minus 4 and x minus 9 equals 0. And what would the two solutions to this be?
Positive 4 and 9.
Very good. And you can double check that by putting positive 4 and positive 9 into this function and find that they should equal 0 and work everything through. So remember those steps. Remember to always check positive and negative pairs wherever applicable. So honestly, if I was doing this in full, working it myself on paper, I might even write the negative pairs beneath them just to show myself these are also candidates, because I tend to do things visually. Yes?
The numbers be different if you wrote it in some way. So my numbers, when I did it, like, the way it was listed was negative x squared plus 13x minus 36. And I got it, but it's in reverse. So like, I got negative 36 plus 13x minus x squared. It's just reversed. So my answers are -4 and positive 9.
-4 and positive 9?
Yeah, I did -4 plus x times 9 minus x.
I'm not sure how that pair would come up either way.
I got my work done. I'll just show you like after class.
I would like to see that. Thank you. This is why I tend to invert it at the beginning to avoid the issue. You could still do it from here, but I'm not used to doing it that way, and it's taking a second to figure out how it would change things. So I do recommend putting it in this form to start with. That is number 8. That's another unfoiling example. Now we're going, where I set it down the paper I'm actually reading from. Number 13 has also been asked about, and that is a quadratic question. So let's take a look there as well. this came up because there is going to be an imaginary answer in it, which is okay. Decimals and imaginaries are okay for this assignment. Decimals will come up a lot in physics, and imaginary just tells us that's not the option we want. So let's go ahead. 3.4 x squared minus 2x plus 16 equals 0. So this is a quadratic version. We are asked to use the quadratic equation. Is this already set up and in the form we want it to then plug into the quadratic equation? Yes, everything is good to go. Nothing needs to be further modified. Just for review's sake, remind me, what is the quadratic equation? X equals? Good.
That's fine, because I can use it on square root of 3 squared x squared all over 2.
Very good. I will never mind if multiple people chime in with a response. And it's okay if it's even the wrong response, because saying anything and even getting it wrong will still help you remember it. If you did say it in unison, you would get bonus points for doing it in like perfect shining style unison, but would be creepy. No requirement to. I would be impressed if a little terrified. So let's start just plugging things in. Our b term is always the one attached to the not squared x, and the negative does go with the term. So our b term is -2. So negative b, we're going to plug in a -2 into b. So ultimately that negative is just going to cancel out, which I usually prefer. Plus or minus the square root of b squared. That's -2 squared. Make sure that you are squaring the whole number. -2 squared should give us +4. Minus 4 times a. Our entire a term is the 3.4. Our entire c term is 16. And then all that over 2 times a. So 2 times 3.4. You absolutely could put this into your calculator in one fell swoop. I prefer not to usually for quadratics, since I'm going to have to do it at least twice anyway, once for the positive and once for the negative. So I like simplifying it so that I can simplify what gets put into the calculator eventually. So let's just simplify this ourselves further before we pull the calculators out. If we go one line down and just start looking at all these terms, -2 will just give us 2. So we've got 2 plus minus square root of. -2 squared will give us +4. Then we have 4 times 3.4 times 16. That's, okay, go ahead and look at calculators.
17.
A little louder.
217.
Thank you very much. Just by getting to this point,
26.
is it 217?
26.
0.6, thank you, sorry. Just by getting to this point, I already know both our answers are going to be imaginary, which is fine. We'll get there, we'll write out the full imaginary answer. That's the point of the problem. And then 2 times 3.4 is 6.8. Okay, so all done. We're at the point where we can start getting things into the calculator. We need to do this once with a positive here and once with a negative here. So let's just look at the two things that I would recommend typing in full into our calculators. tends to give me just the imaginary. If yours doesn't, then we'll work around that. What I would put into calculator here is, open parentheses, 2 plus square root of, that'll open the next parentheses, 4 minus 217.6, close that parentheses. We can then close the first parentheses divided by 6.8. And we're going to need to do the same thing again, but the minus sign here for the negative version. And we will get 2 separate imaginary answers. Okay, so I have apparently forgotten and was misremembering the entire time. My dinosaur calculator doesn't like to give me imaginary answers. So, let's actually do this. Let me rewind a tiny bit. My apologies. If mine doesn't do it, I'm just going to assume at least one other student doesn't do it. Calculator doesn't do it either. So we'll look at how to handle that the old-fashioned way. Let's simplify this just another little piece further. So we can get to 2 plus minus the square root of negative 213.6. Just going to do this operation all over 6.8. So we just did the subtraction. We now have one negative number inside of the radical. The calculator does not like this. At least mine doesn't. Someone else's probably doesn't as well. So what we do about that is, within this number, we can separate the negative 1 out. So what I advise doing is, you can write this on your work. Instead of negative 213.6, we have positive 213.6 times negative 1. And when you have two things multiplied together inside of a square root, you can basically root them separately, as long as their eventual roots are still multiplied together. As an example, let's say we have square root of, give me a funny number.
Negative 437.
I'm going to make that positive 437. Just, we'll deal with the negative part over here. But 437. So, let's see. Okay, I'll do that quickly. We can separate that into, it won't be a clean split, but we can separate it into 100 times 4.37. Everyone good with that? And what's the square root of 100? 10. So we can pull that 10 out. No. Okay, no. I should write it one line at a time. As long as they're both being square rooted, we can just separate the two numbers into two separate square roots. This is a legal move because they're still having the correct operator done on them, just separately this time. And this can then further simplify to 10 times whatever the square root of 4.37 is. We can do the same thing over here. We're just going to separate it into 2 plus minus square root of 213.6 times square root of negative 1. And general mathematical rule. Write it down, remember it. Square root of negative 1 is abbreviated to I. That is the imaginary number It's not actually real, but because it keeps showing up, we had to name it for some reason. Because mathematicians are an interesting bunch. I say that being one of them. So, my work's all bleeding together today, I apologize. This piece here can be simplified down to the square root we want times I. And that I, most calculators can handle an I if you put it in, but for the sake of simplicity, what I would recommend doing is, when you put it into the calculator, if yours doesn't like imaginary numbers, put in the normal 213.6 without the negative and without the I. And whatever it gives you, we just would want to add the I in separately. I would actually prefer, I think, I would probably just solve for this square root. Before moving on. So separately, the square root of 213.6 is approximately 14.62. And the calculator won't break that down any further. I is kind of like X. It's functionally a variable. It doesn't really add the things that don't have an I in it. So that's your answer. It's imaginary, which isn't fun. But this one statement, since it contains the plus and the minus, summarizes both whatever the two answers could possibly be, imaginary or otherwise. I realize my logic's a little all over the place today, I apologize. But if you come across a situation where you're doing the quadratic and both answers are going to be imaginary because the I is just sort of baked into the square root, this is perfectly an acceptable way to leave it, because it doesn't simplify any further. Which means I was actually wrong to write this part up here, and I got ahead of myself. Some calculators might be able to handle that. I can't. Yes.
I put I in my calculator following the 213.6, and it got me two answers.
Three answers?
Two answers.
Two answers.
Yeah, one positive and one negative.
That's because of the plus one.
I only used the minus.
Yes, this would be two answers. It would be one with the plus, one with the negative. So if your machine can handle the I, it would give you two. This is going to come down to user and machine as to whose calculator can further simplify this. Some of your calculators, probably the newer ones, would be able to handle what we had up here and then give you the two. And I hope it would give you the two, since, especially if you actually had a quadratic function in there. Excuse me. But on this assignment, as to what you should write on paper to submit, this is an acceptable thing to write down. I will also, on my key, have what it would look like if a machine did simplify it further, so So if your calculator did automatically simplify it or reduce it as far as the machine could go, I will make sure to know what that is on the key and accept it as correct. But this is a perfectly acceptable answer to this question. So if the I comes up, the square root of a negative comes up, you can write out the I in your answer, that's fine. And if it isn't specifically this piece, you can write it out in this form. Plus minus tells me this is both answers. How you guys doing so far? Okay, big nodding, some thumbs up, okay, nice. That is probably the hardest one in the quadratic section, because I don't think the others should give you that negative problem. I would hope. Maybe 12 might be tricky there. Sorry, real quick, because I don't have my key on me. Okay. Yes, out of 11 through 13, only 13 will give you this complex answer. The other two should have normal, standard, numerical, non-imaginary answers. Yes.
14?
14.
Did 14 not have it?
I got one 14 to back, I did too.
Oh, imaginary answer?
Because the radical gives you a negative 956.
I didn't have 64 in my, but I think I struggled with that question.
Okay, sorry, which one were you asking about?
14.
14. Yeah, that's the one I wasn't. Okay, sorry. Okay, let's take a quick look. 14 would need in this section, you are asked to solve for the unknown variable in the following problems. And this particular question might look like some of the earlier FOIL and solve for variables questions, but because it's equal to negative 15 instead of 0, you can't just do the same trick to solve for things. So we do have to FOIL it and turn it into an ax squared plus bx plus c type question. So distribute the x's in, 16x squared minus 2x equals negative 15. To get it into the correct form, 16x squared minus 2x plus 15 equals 0. And this will definitely give us a complex answer. It absolutely will. So this will give us, your two answers for this one will be of a very similar form. And it is legal to write it this way. So I would do these by hand more so than by calculator. Because I have an easier time getting to this point by hand than I would trusting the machine to get there. Looking at this, I can tell the answer would have been complex because b squared is going to be far smaller than 4 times a times c. As long as 4 times a times c is going to be bigger than b squared, you will have an imaginary answer. Yes?
You couldn't just use like a legal move on this one?
Sorry?
You couldn't just use like a legal move on this one? Like times of 16 out of 15 and do it like that?
I don't know if I'm familiar with the concept you're using. What kind of move was it?
It's a illegal move. You would times the 15 by the 16, and then you would factor it, and then you would, I think you would divide the factor stuff by the 16 after, and then you still get 2 answers.
I'm not sure that's a trick I've ever actually used or been shown.
Okay.
So I'm very curious about that, and I may have to research it. So you've given me homework. Thank you. As for you guys, keep working on these. Come with any questions you have. Friday, I will be attempting to have homework 2 graded so we can get that back and talk about it, and then wrap up number 3. I will look up illegal moves. I need to know exactly what that means. Make sure that your homework is turned in before you go. And unless there's any questions you guys have, you stay healthy, stay safe, and stay warm. It's very cold today. My office is frigid because I can't get my actual vent pour out hot air. So it's cold from the window and cold from the AC. I might need to use lunch in a different room.